So in this problem we got the following. We have to calculate the moment of inertia of a sculpture that consists of three small spherical masses connected with massless rods. Of course, in order to determine the moment of inertia, we first have to specify the axis of rotation. First, we have to find the moment of inertia about the axis passing through the spheres B and C. Then, find the moment of inertia about the axis that passes through the sphere A and is perpendicular to the rod connecting the spheres B and C. In this latter case, we will have to find the kinetic energy of the sculpture if it rotates with the angular velocity 4 radians per second. Now to find the moment of inertia, we have to use the equation that goes like this. The mass times the radius squared plus the mass of B times the radius squared times the mass of C times its radius squared. Now one thing to note is that this is the axis passing through this egg only, whereas in this case we just find the axis passing through both disk B and C. That means that both the radius of B and the radius of C is going to be equal to 0. And as the radius of C and B are both 0, then as we find the moment of inertia, then we will only consider the part of A. So mass of A times its radius squared. And that would be the following: 0.3 kilograms times the radius, which is 0.4 squared. That should give us around 0.048 kilograms per meter squared. And that was for the axis of BC. But for the axis of A, only the radius of A is going to be equal to 0. We do have values for the radius of B, which is 0.50, and radius of C, which is 0.40. So we will use these two to find the moment of inertia in the formula, in the general equation shown here. That means that the moment of inertia of A equals mbrb squared plus mcrc squared. That should be 0.10 times 0.50 squared plus 0.20 times 0.40 squared. And that should give us 0.057 kilograms per meter squared. So for the last question, it's asking us to find the kinetic energy of the sculpture if it rotates with the angular velocity of 4 radians per second. So that means that we're only going to use the moment of inertia of axis A, which is the value that we just found, 0.057. So to find the kinetic energy, we'll just use the formula 1/2 times the moment of inertia times the angular velocity squared. So we plug in values. 1/2 times 0.057 times 4 should give us 0.46 joules for the kinetic energy.